Well, hi, good morning, and thanks so much for joining me in my shop here for the second day with this radio. This is the day where I change out as many parts as I can, hopefully all those capacitors, and I'm part way through replacing the rectifier here. And I was doing a little research, and I think this could be the rarest radio I've ever had in my shop. I don't know how many of these were made, but it may not have been a large number at all. It's made by a company that made radios for just a few years, and this was the last model that they made. They kind of only made one model, I think, variations on one model. And what I want to do is I want to read what I found on Wikipedia about the Breadner company and the radios they were making, because I think it's part of the picture here. Okay, so this is coming from Radio Museum. You should be a member of Radio Museum. I am. And here we are, Breadner Company Limited, Ottawa, Ontario. Let's just read about it here. Well, their trade name was Bradna. Breadner, Bradna. So that's why this radio is called the Bradna. But apparently the radio I have on my bench had a nickname, and we'll find it in this article. So let's just read through this quickly here. The Breadner Company was founded as a jewelry business by Samuel Breadner, and they eventually occupied a large building at 1000 Somerset Street West in Ottawa. I probably walked past that building. Samuel's son Jack became president of the company, and counting on large amounts of inexpensive war surplus material, this family business decided to manufacture portable radios in 1946, and they designed their first model to be supplied for the early 1947 season. During 47, they produced two models, the JBL 27, and within a few months, the JBL 27A, which replaced half the octal tubes of the original with the smaller miniature types. For the 1948 season, they were able to build a full complement of miniature tube radios, I think is what they meant there, or to use a full complement of miniature tubes in their radio. And they renamed this version the JBL 27B, which they advertised as the Minstrel. They also made an AC battery model, the JBL 37, which they advertised as the Gypsy. So that's what I have. I have a Gypsy on my bench here. This was their final venture in the radio business, and they returned to making and selling jewelry until the mid-1950s. So there we are. So they only made a few radios. Here's a picture of them there. This is it here. This picture. So they only made a few models. They only made them for a few years. How many of these radios could they have made? 500 or 1,000 of them or something? I can only guess, of course. But I think the bottom line is, in terms of Canadian radios, this is an interesting one. It's an AC/DC model. It has kind of a look to it. It's probably extremely rare. I may have the only surviving example right here on my bench. This may be the only one in the world. Probably not. There's probably a couple more floating around, but this one's in great shape too. So what this says to me is, Jim, be real careful with this, and you better be successful, because you don't want to end this radio's journey because it's come a long way and it's all alone. Yeah. So I'm working right up in this corner of the radio here, and we can take a closer look. What I'm trying to do, there's lots of challenges in working in these packed radios, and they were probably assembled in a way that made it easier. And coming along later and trying to do some of these things, I'm trying to get this down on that switch terminal down there. I tinned the wire, but getting it to hey, what just fell out? Oh, a screw just fell out. Where did that fall from? Okay, just got myself an extra screw. It's just kind of tight in there. Oh boy. Just have to kind of like sweat it up. It looks like there's a blob of solder that's actually causing a problem there. Let's see if I can sweep it away. get out of there? I don't know. I don't think I can melt it. Got my big pliers on. It's like a big heat sink. I don't think that's not going to work. I have to just tack this up onto it, I think. That's really the only option here. Just hold that wire in place there. Something like that. Okay, a little bit soldering in the blind here. Now I've taken to not videoing my soldering efforts because it slows me down hugely trying to video this kind of stuff. But you know, if I just come on and go, well, okay, I did that, you really have no appreciation of just how difficult some of these things actually are to do. Okay, so I got lots of liquid solder in there. It doesn't look good at all. Looking at it, it looks like it's completely messed. Yeah, just popped right off. Let's try this again. See what's happening. Got it. I can see a strand loose down there. That's not bad. It's pretty good. Just grab that strand there. That'll do. Okay, hey, that's one connection. Okay, sometimes you just have to kind of do these one step at a time and just figure it out as you go. You really can't come up with a entire plan necessarily. So this guy used to be mounted here. So terminals don't have wires, so I had to bring wires over to it. Now my replacement has wires. So one of the wires is this one, which goes to the start of the long resistor. So I'm gonna, and this is a fixed post, so I'm gonna solder the diode to the fixed post. It's gonna make it steady, and I should be able to hook up some looser wires to the other end. I have at the other end I gotta put this wire and the capacitor. And the capacitor goes, where's the capacitor go? It goes from here. Can't remember where it went otherwise. I have to make something up for that. That's what I'm doing. So we're gonna going to get rid of this. And I'm going to try to pull it out with, try to remove it entirely here. Sometimes I'm a little, grab the cutters first. Oh, this is wrapped right around. Yeah, I'm not going to be able to pull it out, I don't think. Because the wire's wrapped right around. Well, yes I can. Oop. Flying solder. There we go. So we'll stick the diode in there. For the little band. Match the schematic doing this. Looking for the little symbol band, a band on here and the symbol. Oh, that's quite a bit of wire. I can afford to wrap more. Lots of wire. I know I should cover this. Hold it. Back up. Okay, I'm going to get this in. You know what I'm doing. You'll see it when it's done. Okay, got that finished, and I used a special capacitor here, this one, for installing across the line or from line to ground or something like that. So, okay, the radio should be operable now. I just have to find a set of tubes for it. We'll see what it does. Well, finding the tube may be more than a little difficult, so I'm looking for 4 tubes. I have 3 of them here. There's a duplicate here. The one tube that I can't find is in my little meager collection here, is the 3S4 output tube. 3S4. And I didn't see any here, but half these tubes have no label on them. The label, for some reason, just rubs right off these tubes. So, and I've never tested all these. I've never gone through, never had to until now. So what I'm going to do is I'm going to go through all these tubes. Whoops. I'm going to test the ones I can. I'm going to try to identify the ones with no identifier. That's a little bit tricky. And maybe in the midst of all that I'll find a 3S4. Otherwise, that's it for this radio. I can't go any further with it. Yeah, that's not true. There's always some sneaky way to do something with it. But in terms of playing it normally at this point, there's really no hope. And the thing about these 1 volt tubes, they're not actually 1 volt. They're 1.6 volts, I think. But we can class them as 1 volt tubes. These are precarious tubes. Fiddle the wrong way and the filament burns out. There's quite a few warnings on this radio and any of them like this. If you pull 1 tube out, you'll burn the rest up if the radio's operating. So you dare not have it operate and pull the tube out. And now, because it's time for something a little bit different, we're going to take a really close look at that, because there's something very interesting going on with that. Let's do that. So first we'll just look with the close-up camera and we'll see what we can see with that, because maybe it's actually nothing too interesting. Let's see. There we go. I think it is. I can see stuff with my eyes that's kind of caught my attention. So it's the, let me get up close enough here. It's those crystals sticking out of it. Now, I've seen stuff like this. It's just in this case, the crystals are really large. Spikes coming out. Now, what could that be? So, what is the metal that's there? I'm really not sure. It could be aluminum. It could be galvanized steel. It could be something like that. It could have some other kind of metal coating on it. I really don't know. But those crystals have come from the metal itself. Is that the metal drifting up into these long pointed crystals? Or is something being captured out of the air and building these crystals? I don't know. Let me see if I can get the microscope onto it. Really take a real close look at it. Okay, so now we're looking under the microscope, and it's a pretty powerful setting. You know, I don't know how much it's magnifying it. Could be 300-400 times. I'm not sure. I'm going to move it just a little bit here. Just see if there's a bit of a better view down in here. Very tricky moving this thing. Whoops. Yeah. There we go. Let's go up here. The camera's vibrating there. So it's, I guess crystals can form like this, just straight little things, like hairs. Like, what would that be? Would that be like 50 atoms across, like a tube made of 50 atoms on a cross section, or how would that even work? Huh. Assuming they are crystals that have grown from the material underneath. I'm just gonna I can move the radio around here. I'm trying to get a shot that kind of looks across the surface of it more. What's that look like? There. What do we got there? We got absolutely nothing there. Let's try here. So I have this camera mounted on a long boom in my shop here, and it's really tricky to move it precisely. I'm certainly not getting anywhere like that. Let's try this. Yeah, I think we may have. But I'm going to put this on full magnification. We're going to take a shot. Whoops, that's the wrong way. Take a shot at getting a maximum view of this. Stop here. I'm on. Oh, come on. Right, whole system's falling apart here. Just hang on. There we go. Okay, there's a pretty good close-up there. The camera's moving around a little bit on its own. Well, there they are, straight as can be. Little tiny hairs coming out of the metal there. Curious stuff. That's about the most we're going to see from it. There's a good shot there. The brown strip in the background is a very, very thin strip separating two halves of the volume control housing. You can't even see it with your eyes. Looks like a big bar in there. It's so tiny it can't even be seen. And there they are again. Just looking everything over. There's a better undisturbed area. You can see the depth of field is very small. The focus depth of field is small. If you look right in the focus area though, there's all kinds of crystals coming up out of the substrate, I guess you would call it, and a few of them managed to grow to be really, really long. And the upper one there at the top of the picture, you can see different colors in it. That's probably some kind of diffraction thing happening, because these things are so small they're probably having an effect on the, they're probably, I don't know, what's the right word? Anyway, they're in the range of the wavelength of light, something like that. That sounds crazy, doesn't it? You can't see stuff that's a wavelength of light. Anyway, there we are. What is it? Well, maybe I should say hi and good morning again. It's now April 6th. It's been quite a few days while I dealt with the problem of the tubes for this radio successfully. And once I get into the tube testing thing, I intend to test lots of tubes. So that's where I've been the last few days. And now we're going to try to make this radio work just by popping in some tubes. So I've changed the diode up here and the capacitor. I changed this capacitor. Hey, let's put this on the tester and see if it's any good. This will be the first capacitor taken out of the radio. Appears to be in pretty good shape. Let's see. Let's see what happens here. Okay, so we're on 25 volts. Watch the eye. So it hasn't opened all the way on 25 volts. That's a bad sign. On 150, I doubt it's going to open at all. So as capacitors go, even though this one looks good, it's pretty leaky. Now back to the radio. See, now it looks like I have a huge collection of these 1 volt tubes, but there's like 1 or 2 in each of those trays, so there's not a lot of tubes in there. But the tubes we need are in there. So we start with 3S4. Now I have to tell you, I'm very anxious about putting these tubes in. 3S4. Because if there's something seriously wrong here, these tubes, they don't survive any monkey business. You know, your regular tubes, 6 volt tubes, you can jam a pretty high voltage on the heater for quite a while. So 3S, it's going in here. Tube sockets look like they're full of dust. Okay, next guy, a 1T4. T4 going between the cans. I don't want to get this wrong. So these tubes are in series, but they're not just in simple series. There's resistors in there. Hey, what's this guy? This is the speaker lead somebody put in. I have to check that out. Next tube, 1 US. 1 US. 1U5, 1U5, 1U5. 1U5. That's going in this spot here. And one more, last tube, 1R5. 1R5. There we go. So all these tubes have been tested. They work. They don't necessarily work great, but they're certainly not dead or anything like that. Now in this radio, if the radio's operating and you pull one of these tubes out, you can probably kiss the rest of the tubes goodbye. That's the situation here. Which always leaves me wondering, well, what if one of these burns out? Doesn't that do the same thing? And I don't know the answer. I'm not going to worry about it right now. One of the things I've noticed is the capacitor here has been tuned. So you look at this capacitor and you can see these outside plates have been bent outwards. All of them have been bent outwards a bit. And that's a sign of a type of alignment work that was done probably in the factory. Okay, I do have a power cord. And yeah, let's work on this speaker wire thing here and see what that's all about. So it's a connection. It's a connection to one of the. I'm going to cut it away to one of the voice coils, voice coil leads, and I'm just going to get rid of this. Somebody was doing something, like an external speaker or headphones or something. That. Now the diode I put in is going to result in a higher than previous B plus. I'm just going to leave it like that. Everything else is okay. Antenna's still connected. Okay, so in most radios I would just basically turn them on with a dim bulb in series. And because they're normal radios normally have 6-volt tubes and stuff like that, they're pretty tolerant to any kind of monkey business. So if this goes poorly, that's the end of it. I only have one 3V4. How can I tell it's going wrong before it goes totally wrong? Would I be able to monitor the heater string voltage at some point and know ahead of time that something's going wrong because that point has got a wrong voltage on it? My plan is to bring the voltage up very slowly using this guy. So before any tube gets too much heater voltage, problem should be resolved. What else could I do? I could put half power or half supply voltage on the radio. That would give me, wouldn't it, half heater voltages, and then I could test them and see if they are really half heater voltages. Which one of those do you like? Well, the fact is, I'm gonna if I start from 0 and I turn this up, at some point I will be at half supply voltage, and these things should be at half tube voltage, and if I have a meter hooked up properly, we should see it. So I think this is well worth doing. I'm just looking at the schematic here on the back. Does it have any voltages written on it anywhere in the heater string? So there's not much voltage written here anywhere. Is this a hint too? The battery voltage here is 7.5 volts. Using a 7.5 volt battery to fire up all these tube heaters. Now, are they? Let's just see. Maybe they are in normal series. So this one comes around. There's a grounding through this 1,000, looks like a 1,000 ohm resistor. So this is a cathode arrangement. So right there, it's no longer straight series. There's something going on here. 1,000 ohms. Let's carry on. Then we come down to this tube next. Just through it straight, nothing funny going on. Then we come back straight through this tube, nothing funny going on. Then we come out, we meet up with this line here. It's a great big 10 meg resistor. I don't care about it. Looks like it's not connected there. Oh, is it? I don't know. Carry on. We make it to this tube. This tube's got 500 ohms in series, in parallel with the heater. So you'd think if you pulled this tube out or pulled this tube out, you break the current completely. You open circuit the heater path. Now, is that really true? Because you still have heater supply through 1,000 ohms. And you can't get a supply to this tube because it's interrupted. These ones pulled out. Is that right? Maybe that's not right. Well, there's no voltages here. I've looked this thing over. It doesn't give you a voltage, but we expect a certain voltage dropping across these tubes, so I could always measure that. Now, if I'm going to pick one of these tubes to measure its heater voltage, which one would I pick? Probably the 3V4, because it's got the highest voltage. So my thinking would be I'd hook up a voltmeter here, watch for the 3 volts. It's probably not exactly 3 volts either. It's probably 3 point something. Let's settle that right now. I'm going to monitor 3V4, 3S4, just for interest's sake. 'Filament voltage 1.4 parallel. Well, 3S4 has a tap in the heater. Tap goes to pin 5. It's also tap goes to pin 5. I don't see any tap on here. You know, there is. They actually show it here, but they don't show it the same. Like in this book, they show the tap right in the center. They usually aren't in the center of the heaters. And usually these taps are about firing up a light bulb. There's no light bulb in this. This is a battery radio. They don't put light bulbs in battery radios. So this probably is dead center, and it's giving you the option. You could run this on 3 volts, or you can run it twice on 1.5, or whatever the actual. So okay, I got it. What's the actual voltage here? So 2.8 or 1.4. So it's actually 1.4. I call them 1 volt tubes, but they're all running on 1.4. 1.4 twice is not 3. It's 2.8. 2.8. So now, could I be fooled? Could I be watching this, and this is going just fine, and meanwhile I'm burning out one down here? Like if that 500 ohm resistor is not there. It's very unlikely though. I also can relate the supply voltage, which is supposed to be 7, to what's that's the way to do it. You watch the supply voltage go up. When it gets to 7.5, there should be 2.8 here, and if there isn't, something got ruined. Okay, I got the plan. I think I can do this very, very safely now. So 3V4, and how do you get the? So I could put a tube extender in there. The 3V4 is kind of up in here. To bring out 2 clip leads to go to the meter. I'd use the tube extender, but the tube extender is actually harder to make connections to than the tube socket. Okay, now which pins? Which pins? Oh. Say on here? No, they don't put the pin numbers on there. 3S4? 3S4. Was I saying 3V4 before? 3S4. 3S4. 1 and 7. Pins 1 and 7. That's all there is to it. Pins 1 and 7. Easily seen. Pin 1 is going to the top of this capacitor. It's going nowhere else. No, there's another wire in there too. So I could get it off here, get it down here. Pretty tight in here. These are tiny sockets. They seem to be tiny sockets. That's good. And then the other clip lead. Now it's hooked up to a wire which is coming here. This yellow one, that's broken off. I believe it's the right one. Let's try it. I think that's all I got to do. Like that. Put a voltmeter on the end of these clip leads. Oh! Better use a ungrounded voltmeter for this. For sure. The other thing about these filaments is if you're going to burn them out, it's going to happen in a microsecond. You just don't get any opportunity to stop it. That's my experience anyway with them. So we're looking for 3 volts, 2.8 volts, but only, so we're looking for 1.4 volts when we get half supply voltage. Hey, that's pretty good arithmetic. Yeah. Here's a quick COVID update here in Canada. Doctors scared out of the wits. Hospitals full. Politicians at the lower level pretending it's not happening. That's what it looks like to me. Boy, we're right on the precipice here in Canada. Literally, forecasts are we will go over the precipice, and what I mean by that is the hospitals will become too full and we won't be able to help people who are getting sick in hospitals. That's what's happening here in Canada. It's really very upsetting. So now, next thing, so I have the voltmeter connected, voltmeter set. Better turn this down now before it's too late. Plug this in. Now, what if there's a short circuit in here? What if I've hooked up to a short circuit? Maybe I did something wrong up here. What will happen? The very, very low voltage supplied, well, it would be a heavy current. There'd be heavy current. How am I going to see that when I'm looking at the voltage? Because there is a current meter on this guy. So sorry about this cable here. I just swing around a little bit. That's a little better, isn't it? Then my hand's going to get in front of this meter too. Unfortunately. I'll see it, but you won't. Now, right now we have a wall of 25 volts ready to go. Don't want that shorting here. Okay, risking the tubes in this radio. I'm hesitant. I'm very hesitant. Let it go through the dim bulbs for no good reason. This guy should jump to action, provided I have this turned on. Is this turned on? That's a good question. It is now. Okay, let's check it with it off first to make sure off is off, and test my setup. There we go. This is current. Would look like a pretty good 0 there. Nothing happening here. That's because the switch is off. Okay, I'm going to leave this on current. The voltage, let's check first. The voltage is 25 volts. We would expect this thing would hardly move, I think. What's the scale on this? We're on the 1.5 amp scale, so that's a quarter amp up to there. Quarter amp. Why even start with any voltage there? Maybe I've done something wrong and the whole thing is going to go on the tube heater. Could I be that stupid? Probably not, but you know, I don't know. You usually know you've been stupid after the fact. Yeah, let's start at 0. Okay, flipping it on. I'm going to turn the volume up for some silly reason, like we're going to hear something. We got a 0 here. This guy won't register anything till it's about 50 volts available. So it's all up to this one on the voltage side. We're on current. I'm going to go up a little bit. Okay, I did not see the meter move. We're at the 25 volts again. This guy's actually trying. But, What do we got here? We got nothing. We got nothing here. Oh. Why would we have nothing here? Why would we have 0? 2-volt scale. This meter's acting up these days. The meter connected correctly. I use clip leads that are reliable. I picked the wrong wire. What was that? There's a little tiny bit there. What was that? Oh, I don't like the looks on that. This is just a meter. This is a meter only. It's just a voltmeter. What I don't like is that when I make contact, there's a little reading here and then it disappears. I have the feeling everything is fine so far. I have that feeling. Another thing we could look for, is there any reason to think the AC is not making it up in here? We are switched on AC power here. Didn't get anywhere. Voltage from building up in the power supply. That's worth looking at. Okay, let's take these off. Yeah, take that off. This power supply is supposed to go to the negative. Where's that? Let's go to chassis. And we're looking for ultimately like 150 volts here. It's a great big 0. I'm on the wrong side of the diode here. Did the on-off switch not work? So if the on-off switch is open, there will be a AC voltage sitting there across the switch. Okay, so looks like a 0. Let's find out. Turn it off. So that's 20 volts AC. Is the switch is on the AC side? So there's a blank spot in my my schematic here. It has a rip. Right where this is where the switch is. Reading across the switch. Not quite the same as reading across here. So one line of the supply soldered up there, and the other side's right here. So we're going to look for the supply voltage now, right on the end of the wire, right on the end of the incoming wire here. And it should be something like 25 volts there. Well, there it is. should see if I want to read the voltage coming on the other side of the diode, which I guess is right here. It says Selenium Rectifier, so that's where the Selenium Rectifier is. Now it's a silicon diode. Silicon. So I could get on the far side of the diode, or even on the other side of the 50 to get on top of this. Yeah, why don't I see what's building up on the filter capacitors here? It's not a filter capacitor, this one, and this one. Yeah, what's building up on those? And once again, I've forgotten, how is the ground done here? So there's a solid to the chassis here, here, here. No, those aren't chassis, those are to a wire. That's right, that's a wire. This is the chassis. 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 So the negative of these is hooked up to the negative bus. So I just find the negative wire, one of these, I found the negative bus. And here's the negative wire. Power off. Oh, this whole terminal strip is loose. The screw's been taken out of here, and the terminal strip is just floating. I'm sure that's a replacement capacitor from the way it's been installed. So, okay. Oh, I've got my phone here. So I apologize now if my phone has been acting up here on my video. I apologize for that. So we want to go in the black. The black wire here, right there. That's good. Okay, so that's the negative, and then we just want to read to the two positives and see if there's something showing up there. Okay, put the power back on for what it's worth. Clip lead doesn't matter. Okay. 200 volts. Well, there's nowhere near there, I'm sure. Nothing. Well, maybe I just don't have enough juice coming in here yet. There's absolutely nothing showing up. I got a bad clip lead. It's terrible when you have to troubleshoot right down to square one all the time. But is my voltmeter working? On AC. What took that long to figure that out? Okay. Back on the black here. And we're looking for, well, 10 volts or something, 0. That's a big 0. Why is that? Why? We aren't getting anywhere here. Okay, back on the negative. That's not gonna work. That's not gonna work. New clip lead. Supply voltage is 25. That's resulting in just a nothing here. Nothing at all. The switch is definitely on. No, it's not. Duh! 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 Okay. Now we get something. Do we get something? Come on. Show me even a volt there. Minus 2. Minus 0.2. Minus 0.2. Well, I really haven't looked across the heater. So in this radio, they use the B+ to drive the heaters. Well, of course, they pad it down with this great big resistor here, a 2500 ohm resistor. Where is that? So that resistor is this guy. 50 and a 2500. 50 and 2500. The far end of the 2500, we should find the remnants of the voltage heading for the heaters. Right on the 7.5. So conceivably, this is 7.5 volts when the radio is operating in an outlet normally. So I can go on that spot. Pretty easy to find. It's just this. We would like that to show 7.5 volts. Assuming all else is working. Just one big zero. Well, let's give it a little more supply voltage here. A little above 40. Made no apparent difference here. Oh my gosh, what is happening? Maybe the battery switch doesn't work? Okay, back to square one. Is there any AC voltage getting to this radio? You should find 40 volts. Actually, there should be 40 volts onto this terminal. Between here and here. Oh. Okay. What am I doing wrong here? This looks correct. We have 46 volts. Definitely on the plug end of the plug, but on the wire end we got 0. How does that happen? How does that happen? I'm down on my knees in case you're wondering about the funny angles of my hands. Clip lead onto this one. Wow, it's days like this I think I couldn't fix a flashlight. Okay, I'm trying to see the contact. There it is. Okay, yeah, it's on the other end of the wire. Good. Now it should also find it here. Well, why not? This is the maybe I have it switched the wrong way. The battery switch. Talking about switching, I'm going to switch cameras. Oh, what are you looking at there, camera? Staring up into the sky. So, well, it looks pretty clear to me. You flip it to battery for battery, and you flip it to AC/DC for AC/DC operation. Is the switch not working? Throw it over to battery. What would happen? There's no battery connected. Oh, wait a minute. Sorry. Standing there holding the camera, not thinking. So I flip it over to battery. Nothing should happen, I think. Some of these radios, when you operate them battery, you take the plug and you have to plug the plug into a socket in the radio chassis. That's not the case with this one. So when you flip the switch here, here it is. Oh, they're showing this in a kind of difficult to look at how they're showing the switch here. Huh. So wait a minute now. This is there's more. There's a couple. What's this switch? Switch on volume control. That's the on-off switch. Why isn't it way over here? That means when this radio is plugged in, all the time this capacitor is energized across the line. Yeah, this either thrown to the batteries. I don't anticipate you to have it plugged in and flip the battery at the same time. That's what I'm worried about. So that's why I'm paying attention to what's going on here. It may even say somewhere. Do never do that. There's the warning about removing tubes when it's operating. You know, like if the tubes weren't at risk and I had, you know, multiples of these tubes, I wouldn't be so hesitant. But one mistake here, one of the mistakes I could make is leaving the power onto this thing while I'm yapping. That's definitely a mistake. Well, I could throw the switch and see if now a lot of these toggle switches actually, when you know, they've got let's just say the switch position doesn't point at which terminals. That would mean they've labeled the switch backwards. That's just craziness. There's really not much chance of that. Could I blow these tubes up by throwing this switch over and trying it with power? Is there a better way to figure this out? Either the switch is just the function, it doesn't function. They've labeled it backwards. I'm stupider than I realize. That's probably the one right there. Well, I don't know what else to do. I'm going to mill around here all day, so I'm going to, power's killed, throw the switch, and reduce the voltage because we're just trying to detect it. Ooh, bad word to use. And now we read across from there to here. Oh my gosh, there's a voltage coming up. Oh, went away. The actual voltage that we should see is around 30 volts. 40 volts actually. So we should see 40 volts here. I'm going to throw the switch. So, you know, there's 6 terminals on the switch. These are the 2 center pole terminals. Is it that I didn't solder it properly under here where you can't see it? Is that what happened? I haven't soldered it. Power off. I think I soldered it, but I didn't. It's very hard to see there. Let's go and see there. I'm going to find the wires never got soldered or something dumb like that. Okay, up, back there. Okay, I got to change my camera setting here. Unfortunately, I'm going to keep the camera running. keep the video playing rather. So we've had many beautiful sunny days here in a row. That's why I haven't been in the shop. I've been outside enjoying things. Concentrate here, Jim, what you're doing. Let's try that. Let's see if we can see what's happened up here. It's just so dark underneath this capacitor. Okay, swinging it out. There's the connection. Did I solder that? Let me wiggle it. Thumb in there. Well, it sure looks attached. I'll try pulling it out. It looks, even if it's not soldered, it certainly looks like it's making contact. Did I solder you in there? Soldered in. So now we got a situation here where it looks like the switch is broken, and that's another very unlikely thing to have happen. It can happen. This is the kind of switch that's thrown 5 times in its whole life. I just did 3 of them right here. Ohmmeter reading through the switch, even with wires attached. Power off. Power's off. Ohmmeter reading through the switch. Okay. Terminal, and I can't see the meter. It's open. You gotta be kidding me, really? Let's try the other side. What about the other side? It shows open too. Okay. Throw the switch. Switch has kind of a crummy feel to it also. Oh, wait a minute. That's right across the wrong way. Well, how did that happen? Through some resistor or something. Okay. Now, so the way the switch is, we should see shorts from the other terminals. Man, they just hit that switch up here. Yeah. How do you prove the switch is shot? You know, I've pretty much done that. Why would the switch be shot? Dirt inside it? Usually the switches break because of metal fatigue, or some part inside breaks into pieces, and then that's the end of the switch. There's a bit of a springy thing in most of them. The springy thing can give out. Very, very strange. I'm just not buying what I'm seeing here. I'm going to try to clip on to the terminal here. Okay, and then clip on to the other terminal, which is this one. Put the power on, short these, the radio may come on. Except it's a double pole switch. You have to solve both sides. Okay, so we're on resistance right across the switch. So that should have closed it. It should have gone to 0 ohms. Should be showing 0 right now, so I'm wiggling the shaft around, you know, as much as I can. I don't know what to make of those readings. Good thing. Who knows what those were. I cannot find a short in the switch in any position. Let's try the other side here. It's just what I'm finding is hard to believe. Come on, let go. It's not something you want to just go, oh yeah, it must be a switch. Let's change all that. That's not. I don't think that's a good idea. The other side of the switch is here, or the center post, and nothing. So it should be a short there. Should be a short. Let's put a short on it. Just see. Ooh, a little hard. I'll put a short. Kind of dumb. I'm going to put a short down here. This is how. Oh man, really, square one. You got to go there though when these things happen. Something's happening. It's not quite making sense. Could be you don't have the information you need to make sense of it. I think at this point it's just from here on it's all nonsense. Okay, try the other side of the switch. Out. Bit of an assumption that this was making electrical contact because it's so hard to see up in there. Oh my gosh, I can't do this one like that. Okay, that's definitely on contact, and there's just nothing happening with this switch at all. Now you'd think it would be stuck one way or the other. It wouldn't just be open. I'm really on the terminal. Well, it's really very, very disappointing. I really thought I was going to come in here and we were going to hear this radio make some noise right away. And I just finish off my video with a quick little there. But it turns out there's no there. Switch. So, you know, before I go any further, I'm going to stop and think. One thing I can do is I can make this radio permanently a power radio and do away with the battery side of it. What are the chances of it ever being operated on battery again when it has a plug? Kinda nil. People have electricity in their barns these days, so no need for a battery operated radio. I'm going to think about this a little bit, and we may just out with the switch and solid all the wires up in here, and it's a plug in the wall radio from then on. Okay, well, thanks a lot for watching. This just did not turn out at all how I expected. What I'm going to do now, I got 50 minutes of video here, and I've got another 50 minutes elsewhere. Oh no. Hey, have a great day. See you on the next video.